Here are solutions to perfect problem 7 for Math 111. First one, here's some, this is the polynomial we're going to use in this problem. It says list all possible rational roots. To do that, you have to know that all rational roots are, all are integer factors of this number divided by integer factors of this number. So what I mean by that is the only number that divides into 1 is 1, maybe plus or minus. And what goes into 4 is 1, 2, and 4. So what that tells me is this can be plus or minus 1 divided by 1. It could be plus or minus 1 divided by 2, which is 1/2. Or it could be plus or minus 1 divided by 4, 1/4. So these 6 numbers right here are the only possible rational root that this polynomial can have. Not the only possible roots, but the only possible rational roots. Test the possible rational roots from part A until you find one that works. Little hint, test the integers first. Test plus or minus 1. I'm kind of telling you that one of these things right here will work. So let's figure this out. F of 1 would be 4 plus 8 plus 3 minus 2 minus 1. That right there does not equal 0. So what that tells me is 1 is not a root of this polynomial. Alright, that probably tells me that -1 is. Let's see, f of -1. If we stick in a -1 everywhere you see x, you'd get 4 times 1 is 4. You get 8 times -1 is -8. 3 times 1 is 3. -2 times -1 is 2. And minus 1. And let's see here, adding up the positive numbers, I get 9. The negatives, I get 9. 9 minus 9 is 0. So that's good. I figured out that -1 is a root. It's just one of the roots, but that'll be enough to get me started. Let's see, now I can use polynomial long division to factor out the factor corresponding to the root. What I'm saying there is if -1 is a root, x minus -1, in other words, x plus 1, is a factor. Probably the most important thing you'll get out of polynomials, that if -1 is a root, x plus 1 is a factor. So if x plus 1 is a factor, I can do x plus 1 divided by 4x to the 4th. Oh boy. 4x to the 4th plus 8x cubed plus 3x squared minus 2x minus 1. Now if I use polynomial long division, I want to write up here a number so that when I multiply it by x plus 1, I get rid of this 4x to the 4th term. What that number is 4x cubed. 4x cubed times x is 4x to the 4th. 4x cubed times 1 is 4x cubed. Now what I'm going to do is, from this I want to subtract this. So 4x to the 4th minus 4x to the 4th is 0. 8x cubed minus 4x cubed is 4x cubed. And then I can bring down the rest of the stuff. Maybe I'll just bring down the next term, 3x squared. And up here I want to write something so that when I multiply it times x plus 1, I get 4x cubed. And what that is 4x squared, because 4x squared times x is 4x cubed. 4x squared times 1 is 4x squared. And now if I subtract, these go away. Good. 3x squared minus 4x squared is -1x squared, or just -x squared if you prefer. And then I'll bring down the -2x and repeat. Stick a -x up here because -x times x is -1x squared. X times 1 is -x. Now I subtract. -x squared minus -x squared is 0. -2x minus -x is -2x plus x, which is -x. -x, bring down the -1. Now I need to put something up here so that when I multiply it by x, I get -x. That's -1. Gives me -x minus 1, and I almost have enough room to point out down here that I get no remainder, which is a good thing. We don't want a remainder here. So what that tells us is that 4x to the 4th, try that again, to the 4th plus 8x cubed plus 3x squared minus 2x minus 1 factors into x plus 1 times 4x cubed plus 4x squared minus x minus 1. Whew, all right. Guess that's the end of part C finally. D says, factor this guy the rest of the way. We started in part C, let's finish it in part D. It gives us a little hint to factor by grouping. So I'll leave the x plus 1 alone, but then from this big mess over here, what I'll do is I'll factor out from these first two terms 4x squared, their greatest common divisor. And if you pull out 4x squared from these first two terms, what you're left with is just x plus 1. X squared plus 1? No, x plus 1. Yep. And now I want to pull something out from these last two terms so that I'm left with an x plus 1. What that ends up being is negative 1. So what I have here, I'll leave the x plus 1 alone. In here I have two terms. There's one, there's the other, and they both have an x plus 1 in them. So I can factor out an x plus 1 and be left with 4x squared minus 1. Maybe I'll write some equals here. And now you don't need this extra set of parentheses. So I got x plus 1 times x plus 1. Let's see, 4x squared, that is an x, minus 1. Hopefully you recognize that as a difference of squares, which means that it factors as 2x plus 1 times 2x minus 1. So what I've done is I factored f of x into 4 linear terms. What that tells me is, maybe over here I'll write the roots. And I want to know the multiplicities also. Let's see, the first root, if x plus 1 is a factor, x minus 1 is a root. That shows up twice, so its multiplicity is 2. See if I solve when these guys equal 0, if I do 2x plus 1 equals 0, subtract 1 from both sides, get x equals negative 1/2. So that tells me that negative 1/2 is a root, but it just shows up once, so its multiplicity is 1. And this guy, if you solve this using these same methods, you'll get positive 1/2, and its multiplicity is 1. So I guess that's fine. These are the three roots, and these are the multiplicities. Determine the y-intercept. All right, y-intercept is the easiest one to figure out if you remember what it means. Y-intercept comes when x equals 0. Go back up to the start. If x equals 0, this goes away, this goes away, this goes away, this goes away, and we're left with just negative 1. In other words, f of 0 equals negative 1. So y-intercept is just at negative 1, is negative 1. Maybe I'll write, or when x equals 0, y equals negative 1. Either of these I'm fine with. I don't care which one you use. Determine the end behavior of f of x. Let's see, the degree of f of x of f is 4, which is even. The leading coefficient of f is, I think that was also 4. Let's see here. Yeah, it's 4. So leading coefficient and degree. Degree is 4 because of this 4. Leading coefficient is 4 because of this 4. Is 4, which is positive. And so using these two things I get, so as x goes to infinity, f of x is going to go to infinity. And as x goes to negative infinity, f of x is going to go to negative infinity. All right, then using all this stuff that I figured out in parts D, E, and F, I'm supposed to sketch a graph of this guy. All right, an approximate graph. That's important there because all this is approximate. Let's see, I know the y-intercept is negative 1. So maybe there's negative 1 right here. I know the end behavior, it's going to be going, whoops, this is supposed to be positive infinity right here. Oh, jeez. All right. Yeah, it goes up on both sides because the degree is even and it's positive, so it goes up on both sides. Sorry about that. Let's see, roots. We got -1 as a root, so maybe here's -1. I'll put a dot right there. And then I know -1/2 is a root. So here's -1/2. And then this right here was -1. I really should draw this bigger. Start over. All right, let's put -1 down here. Let's be a little smarter about this. -1. Let's stick -1 way the hell out here. -1. Let's see, another root is -1/2. And the last root is +1/2. So I know that my graph has to go through these 4 points. I know that the end behavior is positive on both sides, so it's going to end up going up this way and up this way. And I also know that the multiplicity is even at -1, but odd at the rest of them. So what's going to happen here is we're going to kind of hit this guy and bounce off. We're going to hit this guy and go through, hit this guy and go through, and then hit that guy and go through. Something like that. It's supposed to go through all those points. My graph isn't perfect, but if I make the dots a little bit bigger, maybe it's close enough. Yeah, good enough. And that is the end of this perfect problem.